This call is now being recorded.
Okay, good morning all. Again, today we have with us the expert Dr. Minhaj Ahemad from St.Vt. Palloti, College of Engineering, Nagpur. So today he will discuss the material requirement planning. So without wasting much more time, I request Dr. Minhaj Ahemad sir to continue with the presentation.
Yeah, good morning, friends. Good morning, friends. Today we are going to see the material requirement planning. So, friends, material requirement planning is basically a computational technique that converts the master schedule for end product into a detailed schedule for the raw material and components used in the end product. In the last lecture, we have seen the aggregate production planning as well as the some glimpses of master production scheduling. So basically, material requirement planning, it's a sort of computational technique that converts the master schedule for end product into a detailed schedule for the raw material and component used in the end product. The detailed schedule identifies the quantity of each raw material and component item. It also indicates when each item must be ordered and delivered to meet the master schedule for final product. So MRP is often thought of as a method of inventory control. It is both an effective tool for minimizing unnecessary inventory investment and a useful method in production scheduling and purchasing of material. So friends, material requirement planning is a computer-based inventory management system designed to assist production manager in scheduling and placing order for items of dependent demand. Dependent demand, the distinction between independent demand and dependent demand is important in MRP. Independent demand means that demand for a product is unrelated to demand for other item. Final products and spare parts are example of item whose demand is independent. So independent demand pattern must usually be forecasted. Dependent demand means that demand for the item is directly related to the demand for some other item, usually a final product. The dependency usually derives from the fact that the item is a component of the other product. Component, parts, raw material, and some assemblies are example of item that subject to dependent demand. So dependent items are component of finished goods such as raw material, components, parts, and sub-assembly for which the amount of inventory is needed. So MRP is a dependent demand production planning and inventory control system. So it is a dependent type of demand production planning and inventory control system. MRP integrates data from production schedules, master production schedule with inventory records, scheduled receipt and the bill of material to determine purchasing and production schedule for the component required to build a product. So how it evolves during the years. So MRP is a material planning methodology which is developed in 1970s, making use of computer technology. The main feature of MRP are the creation of material requirement via exploring the bills of material and time phasing of requirement using posted average lead times. There is one another concept that is known as material resources planning, that is also termed as MRP2. It was developed at the second generation of MRP and it features the closed loop system. Production planning derives the master production schedule, which derives the material plan, which is the input to the capacity plan, feedback loops, etc. So the goal of the MRP, how does MRP work? The aim or goal of the MRP is to supply information that will enable the company to have enough inventory on hand to fulfill demand, and it is available when it is needed at the desired quality level that meet specification but does not have to exceed it and at the lowest price. So this is the requirement. A good MRP or material requirement planning can provide the basic needs of keeping inventory level low as well as fulfilling the customer's demand or expectation as well as for time delivery. So there are two important questions to ask here. How much of an item is needed? When is an item needed to complete a specified number of units in a specified period of time? The MRP process involves the following step. It determines the gross requirement for a particular item. It determines the net requirement and when order will be released for fabrication or sub-assembly. Net requirement means total requirements minus available inventory, that is the net requirement. It is also equal to gross requirement plus allocations, okay, plus scheduled receipt. So where demand for the item ends, product must often be forecasted. The raw material and component part used in the end product should not be forecasted. Once the delivery schedule for end product is established, the requirement for the component and raw material can be directly calculated. For example, even though demand for automobiles in a given month can only be forecasted, once the quantity is established and production is scheduled, we know that 5 tires will be needed to deliver the car. Okay. Then MRP is the appropriate technique for determining quantities of dependent demand item. This item constitute the inventory of manufacturing, raw material, work in process, component parts, and some assembly. So that is why MRP is such a powerful technique in planning and control. So to develop a MPS, first of all, for the end item, the MPS is adjusted according to the following. We have to create schedule, identify the specific part and material required to produce the end item. This bill of material will be useful here. Determine the exact numbers needed, determine the dates when order for those materials should be released. So this is a trumpet and sub-assemblies of that. So how to make the bill of material? This is the trumpet is an 8 item. So bale assembly 1 in number, wall casing assembly 1 in number, slide assembly is 3 in number, and walls 3 in number. So all these are given in this format is a bill of material. It took bill assembly, it took 2 weeks lead time. This took 4 weeks. Site assembly, slide assembly is 2 weeks, and walls 3 weeks. So this is the bill of material flowchart for. So MRP is a computer-based information system that translates master production schedule requirement for end items into time phase requirement for sub-assemblies, components, and raw materials. The MRP is designed to answer 3 questions: what is needed, how much is needed, and when it is needed. So these are the various benefits: better response to customer order, faster response to market change, improved utilization of the facility and labor, reduce inventory level. These are the benefits of MRP. So MRP is a dependent demand technique. We have seen what is dependent demand. This MRP, it uses this bill of material, on hand inventory data, expected receipts, master production schedule, and lead time information. These are known as the input to MRP. Okay, so as to determine the material requirement. So these are the MRP input: this master schedule, bill of material, inventory record. Okay, these are the inputs to the MRP. and after processing, we'll get the output in the form of this order, planned order scheduled, order release, changes if any, then performance control report, planning report, exception report, and inventory transaction. So these are the output which we got from this MRP. So master production schedule, we have seen what is master production schedule. This is an input to MRP. So how many and when the company plans to produce each item, it is derived from this aggregate plan. We have seen this in the last lecture. Then bill of material is nothing but list of component, ingredient and material needed to make product, provides product structure. Items above given level are called parents and items below given level are called children. So these are the content for bill of material. This is nothing but the list of component. We have seen the example of trumpet. So bill of material is the list of component, ingredients and material needed to make a product. So this is the assembly diagram and product structure. So if we consider the finished chair, these are the front leg, back leg, seat, crossbar. These are the supports. So these are the various component of a finished chair. These are another example for bill of material of various component. This is how we can calculate the various parts and their number of assemblies. So in this fashion, the bill of material will generate. So this is another input to MRP, that is outstanding purchase order, that this is scheduled receipt. Accurate inventory records are absolutely required for MRP or any dependent demand system to operate correctly. So it reflects the quantities and scheduled receipt. We should be accurate. And lead time, the time required to purchase, produce or assemble an item, this is known as lead time. For production, it is the sum of the order, weight, movement, setup, store, run time of the product. Then for purchase item, the time between the recognition of a need and the availability of the item for the production. Then time phase product structure is there for the various time phase structure. Okay. So this is the time phase structure. 1 week, for this it is 2 weeks. Please mute your mute your sound. There are disturbance. Please mute.
प्रलय मेश्राम,
Please mute
माइक
your.
को म्यूट करो आप अपना, स्पीकर म्यूट करो. प्रलय मेश्राम.
So these are the time phase. So this gives a time phase record of various elements. It may be inventory status. Okay. It may be the lead time. Then there are MRP outputs. We have seen the figure. The MRP output, let us see the primary output. It is a planned order, a schedule indicating the amount and timing of future. It may be production, it may be purchase order. Then the secondary type of MRP output, you'll got the performance control report. It is about the missed deliveries and stock out. Then planning reports, the data useful for assessing future material requirement. It is about purchasing commitment, if any. Then exception reports, it may be related to some scrap rates, excessive scrap rates, and so on. So MRP processing, it takes the end item requirement specified by the MPS and explode them into time phase requirement for assemblies, parts, and raw material offset by lead time. Okay. So these are the week number. These are the outputs, gross requirement for this week 1, week 2, 3, 4, and so on. So gross requirement is the total expected demand, schedule receipt, and project on hand, that is the expected inventory at the beginning of each time period. Net requirement is the actual amount needed in each time. Planned order receipt and planned order release is the quantity expected to be received at the beginning of the period offset by lead time, and the planned amount to order in each time period. So the MRP is based on the product structure tree diagram. The requirements are determined level by level, beginning with the end item and working down the tree. The timing and quantity of each parent becomes the basis for determining the timing and quantity of the children item. Directly below it, we have seen the parent and children item. If product is considered as a parent, subassembly, we can say S1, S2, whatever. And then the component in that subassembly is termed as children. We can call them. For example, a shutter having frames and wood section. So this is the master schedule for shutter. This is the week number. Okay, so shutter, the lead time is 1 week. Gross requirement, scheduled receipt, project on hand, net requirement, planned order receipt, planned order release. Similarly, frames, similarly, wood section. So all this is given in this example. Updating the MRP system. An MRP is not a static document. As the time goes on, some order get completed, other order are nearly completion. New order will have been entered, existing order will have to be altered depending upon the delays, missed delivery, and quantity change. So it's a dynamic sort of documents. So updating the system, two basic system, that is regenerative system and net change systems are there. Regenerative system, here MRP records are updated periodically. Okay, essentially a batch system that complies all changes that occur within the time interval and periodically update the system. Net change system, MRP records are updated continuously. In regenerative, it is periodically updated, and whereas in net change system, it is updated continuously. The production plan is modified to reflect changes as they occur. So this is net change system, and this is the regenerative system. So theoretically, MRP system should not require safety stock. Variability may necessitate the strategic use of safety stock because it is there in the inventory control, but in MRP, it is not required. A bottleneck process sometime or a late delivery of raw material may cause shortage in some downstream operation. When lead times are variable, the concept of safety time is often used. So safety time, scheduling order for arrival or completions sufficiently ahead of their needs so that the probability of shortage is eliminated or significantly reduced. Then lot size rules are there, like economic order quantity, lot for lot ordering, that is the order or run size is set equal to the demand for that period, minimizes investment in inventory, it results in variable order quantities. Economic order quantity, we have no, we have, when we study the inventory control, then this term comes repeatedly. Economic order quantity can lead to minimum cost if usage of the item is fairly uniform. So economic order quantity is generally that quantity in which we order when it is required and it is feasible economically. Then periodic order quantity is also there. So this is an example for lot size. So we'll escape this because it will take so many times. So this is economic order quantity. For this, please go through some textbook, reference book. For the examples, it is not possible for me to solve the example here, numericals, but it is important with respect to the GATE exam. So my suggestion to all of you is to please go through any standard. There are a number of production planning and control, industrial engineering and operation management books are available. So please go through any of the book. You'll find lots of examples. Then there is periodic order quantity. So the periodic order quantity it or economic order quantity generally attempt to minimize the total cost of ordering and carrying inventory and is based on the assumption that demand is uniform. Often demand is not uniform. So in that case, EOQ does not produce a minimum cost. So the periodic order quantity lot size rule is based on some theory as the economic order quantity is also based on that. So it uses the EOQ formula of economic point at which it is feasible to order. So this is how it is used by this formula EOQ divided by average demand per period. So you can find out the periodic order quantity. So friends, this is again an important point, MRP evolution, how MRP evaluate. So it is based on the closed loop MRP, then closed loop MRP, and then there comes MRP2. MRP, the difference between closed loop MRP and MRP is that in this MRP, it is having a feedback system which make it a closed loop. Then there come MRP2. This is not material requirement planning because it is known as manufacturing resource planning. So here this RP stand for resource planning. It is based on the schedule and purchase material. It coordinates manufacturing resources. And there is also a term which is known as enterprise resource planning, which come after this MRP2. It is known as enterprise resource planning. So closed loop MRP is basically, suppose this is MRP, capacity planning, master production planning, master production scheduling. So if it executes capacity plan, material plan, then it is okay. And otherwise, you have to, a feedback system is there. This is how a closed loop MRPs looks like. So there is manufacturing resource planning MRP2. MRP2, it is the goal is that plan and monitor all resources of manufacturing firm. Then manufacturing, marketing, finance, engineering, all this comes under this MRP2. Let us see what exactly enterprise resource planning is. Enterprise resource planning is a computer system that integrate application program in accounting, sales, manufacturing, and other functions in the firm. This integration is accomplished through a common database shared by all the application program. It produces information in real time and ties in customer and suppliers. So this is the typical ERP system. All these are the element of an enterprise resources planning. So there are various modules of ERP. This is supply chain, this is customer relationship, human finance, basic MRP. Okay, now we have to complete one more topic, which is lean manufacturing, friends. So I hope you'll understand the material requirement planning. What exactly MRP, what are the inputs, what are the outputs of MRP, on which it is based upon. Apart from that, we have seen in short what is ERP, what is MRP2, that is manufacturing resource planning and enterprise resource planning. Now, friends, let us see what is lean manufacturing in short, what exactly lean manufacturing is. Lean manufacturing is basically a manufacturing philosophy in which It stresses on eliminating waste and reducing the resources. So lean manufacturing is a way to eliminate waste and improve efficiency in a manufacturing environment. It basically a Japanese technology. So lean manufacturing is a production of goods using less of everything compared to traditional mass production. If someone from you, if you are from mechanical engineering, you must know the lean mixture in thermal engineering, the lean and rich mixture. So lean means less quantity of fuel is used and more quantity of air is used. So lean manufacturing is basically based on leasing the waste, lessening the human effort, reducing the manufacturing space, investment on tools, inventory and engineering time to develop a new product. So lean is a management philosophy based on Toyota Production System, TPS. It is also known as uh, Toyota Production System. It is invented in Japan. So with lean manufacturing, you'll be able to enhance value for your customer by improving and smoothing the process flow and eliminating waste. So lean was generated from just in time. Just in time is another concept. It is also a Japanese concept. It says that the product, the component, the material, whatever, it should be arrived only when it is required. So there will be no utilization of unnecessary space, then money or investment. So it is a just-in-time philosophy of just-in-time is supplying customer with exactly what they want and when they want it. So just-in-time supplies and components are pulled through a system. So this is a pull type of manufacturing to arrive where they are needed and when they are needed. Okay. Now this lean manufacturing is based on waste reduction. So what exactly waste is? So waste, as we know, waste is anything that is not adding value to the customer product. So products being stored, inspected or delayed, products waiting in a queue and defective product do not add value. So this is also termed as waste. So generally there are seven standard waste, that is overproduction, queues, transportation, inventory, motion, overprocess and defective products. So overproduction, producing more than the customer order or producing excess production is also a waste. It is treated because it utilizes more space, more inventory, more material. So producing more than the customer order or producing early inventory of any kind is usually a waste. Then queuing, that is queues, ideal time, storage and waiting or waste. Transportation, moving material between plants, between work centers, and handling more than once in is also comes under waste. Then unnecessary raw material, unnecessary work in process inventory, finished good, this is work in process, WIP work in process, finished goods and excess operating supplies, unnecessary motions, movement of equipment or people from one place to another place which do not add any value, over processing and defective products. So these are the seven waste which are identified. So friends, lean manufacturing is sometimes called the Toyota production system because Toyota motor companies, these two, E.G. Toyota and this Ohno, Mr. Ohno are given credit for its approach and innovation of lean manufacturing in Toyota production system Japan. So these are some principles of TPS or lean manufacturing, work shall be completely specified as to content, sequencing, time, and outcome. So every customer supplier connection, both internal and external, must be direct and specific, specify personnel, methods, timing, and quantity of goods or services. Product and service flows must be simple and direct. Any improvement in the system must be made in accordance with this scientific method at the lowest possible level in the organization. So these are then, since the Toyota production system requires that activities, connection, and flow path have built-in test to signal problem, and automatically gaps became immediately evident. The result of this are improvement in reliability, flexibility, safety, and efficiency. So this lead to increase in market share and profitability. So this is how in 1915 this St.Vt he have invented the selective assembly and interchangeability concept. Then as the time passes, then Henry Ford, Taylor, Gilbert, and then there comes lean manufacturing by these two gentlemen. So these are the key lean manufacturing techniques, that is 5S, SMED, Kanban, and cellular manufacturing. So what is 5S? 5S basically, these are the 5 terms, Japanese terms. This is strategy for creating a well-organized, smoothly flowing manufacturing process. So these are the 5S, which is sort, stabilize, shine, sustain, and standardize. Okay. This is sorting, stabilizing, shine, standardize, and sustain. So before implementation of this 5S, these are the condition, and after implementation of this 5S technique, these are the post 5S application examples. So there are various benefits of applying this 5S. It avoids wasted motion, increase safety, eliminates unnecessary product processes, offer and reduces the cost. There is another concept of single minute exchange of dies, that is known as SMED. This method that focuses on rapid conversion from manufacturing one product to the next. So SMED need to be treated as a constant improvement program. So here basically focus is given on reduction of setup times. Okay. If you want to change from one product type to another product type, we need so much setup to change the tool, to change the jigs and pictures and so on. So this single minute exchange of dies, this SMED, this method focuses on eliminating that excess time, on minimizing it by using various technologies. Suppose this before conventionally this is part A, and if you want to start part B, there are 2 hours time is required for setup change and so on. It may be internals and external, whatever. But after implementing this single minute exchange of dies program, the time required for switchover from one part to another part is drastically reduced from 2 hours to 45 minutes. So external elements of work can be completed while the machine is still running. For example, get to the next tool, get all your clamps, get lifting equipment in place, put equipment away, etc. Internal element of work can only be done while the machine is stopped, like changing the tool, adjust the machine depth, sharpening the tool. This is we have to perform this only after we have stopped the machine. But while the machine is running, we can perform this activity. So this will reduce drastically the time. Before we in previous conditions in conventional method, we wait for complete stop of machine and then we switch from part A to part B. But in this method, this will drastically reduce our time. So these are the examples of SMED. Okay. So by this, we can reduce the time drastically. We can reduce the time from changing over from product A to product B. Then there comes another terminology, that is Kanban, a system that uses replenishment signals to simplify inventory management. Kanban is basically uses cards, and it gives permission to the one product for replacement, and uses the card system, a system that uses replenishment signal to simplify the inventory. It is basically using inventory management. Is usually use signals that are cards, hold product, what to make, when to make, and how much to make, and where it is to be sent. All this is written in that card, and the cards stay attached to the bin that hold the product. When bin is empty, it is returned to the start of the assembly line for replenishment, and full bins are returned to the customer and the cycle continue. So this will drastically reduce the unnecessary uh, work, unnecessary time consumption. So it is Kanban system. So these are the benefit of Kanban system. It reduces the inventory, it eliminates, it is simple, effective, and inexpensive. It improves the lead time. So increased overall production, reduce amount of floor space required, reduce manufacturing lead time. There are certain disadvantages also, difficulty involved with changing process to implement lean principles, long-term commitment required for this lean manufacturing and the processes under this lean manufacturing. So let us see this slide, how people benefited from lean, in what term. So these are the elements like communication. If we talk about traditional manufacturing system, which is in that the communication is slow and uncertain, whereas in case of lean, it is fast and positive, and improvement in quality and coordination. So these are the various elements, and these are the comparison with how people benefited from lean and how customer benefited from lean. So we'll see that in around 70 to 90% improvement in the time response with respect to hours in lean manufacturing in comparison to traditional manufacturing, when it took weeks to complete the accomplish the task, whereas in lean manufacturing that weeks converted to hours. Customization is quite easy. Okay, the reliability of delivery is consistent, whereas in traditional manufacturing it was very difficult. erratic. So overall, how people benefited and how customer benefited from lean is which is shown in this figure in this table. So this is the house of lean. These are the just-in-time concept. These are the culture of continuous improvement. These are the various benefits. Ultimately, we got the highest quality, lowest cost, shortest lead time by limiting waste and activity, and we get the standard work, total production maintenance, value chain. So friends, that's all from my side. So that's all from my side. Over to you, sir.
Hello,
Yes, sir.
students. Anyone wants to ask any question? Do you have any doubt?
Yeah, please welcome.
अगर कुछ पूछना चाहते हैं तो आप पूछ सकते हैं. You can unmute your mic and ask, or otherwise you can put your doubts on the chat box also. किसी को कुछ पूछना है, कोई डाउट है, पूछ लीजिए. Or else we have to conclude this session. Okay, I think there is no doubt from the student side, sir.
So thank you, sir. Thank you very much.
So thank you very much, sir, for the very wonderful session and informative session. Definitely, this session will be definitely benefited to the students, and the student will definitely take most of it.
Actually, sir, what happened that this needed this type of, there are so many examples which are included, but it is not possible for me to take that example. I've tried and we have successfully done this in that previous lecture, but with respect to this MRP, there are so many numericals. So my suggestion to all the participants is to go through the standard textbooks and go through all the numericals, because in GATE it is asked. Uh, so please go through the numericals. So that's all from my side, sir. Thank you.
Thank you very much, sir.
Thank you, sir. So I'm leaving, sir. Thank you.